Hello everyone, we will discuss the parameters of the two-port network in this lecture. There are four physical variables representing the two-port. They are the currents and the voltages of the two-port. If we use any two of them to describe the other two, there are six combinations, and six sets of parameters and equations accordingly. Firstly, we will introduce how to express the port's currents in terms of the port's voltages. The corresponding parameter is the G parameter. This is a two-port network, and these two equations in terms of the G parameters express the port's currents I1 and I2 in terms of the port's voltages U1 and U2. Our aim is to determine the coefficients G11, G21, G12, and G22. If we know the internal structure of the network, we can find the relationships between the port's voltages and the currents by using the analysis methods discussed in previous lectures. Then get the coefficients. But if the internal structure of the two-port is unknown or very complicated, how to find the G parameter of the two-port? In fact, one important reason for learning the parameter of the two-port is that for a complicated network, its parameters can be measured by experiments. Now let's see how to determine the parameters by experimental measurements. From these two equations, you will find if U1 or U2 is said to be zero respectively, the relationship between the voltage and the current becomes simpler. Firstly, if we let port 2 be a short circuit, that is U2 equals 0, then I1 equals G11 times U1, and I2 equals G21 times U1. If we connect the voltage source to port 1 and measure two ports currents by ammeter, then we can determine G11 and G21 of the G parameter. Express relations by expressions. G11 equals I1 over U1 when U2 is 0. Because I1 and U1 belong to the same port, G11 is called the input conductance of port 1. G21 equals I2 over U1. Because I2 and U1 don't belong to the same port, G21 is called the transfer conductance. Similarly, we let port 1 be a short circuit, that is U1 is 0, connect a voltage source to port 2, and measure two ports currents. Then we can determine G12 and G22. When U1 is 0, I1 equals G12 times U2, and I2 equals G22 times U2. G12 equals I1 over U2 under the condition that U1 is 0 is called the transfer conductance. G22 equals I2 over U2 and it's called the output conductance of port 2. Because we used to regard port 1 as the input port and port 2 as the output port. Since the two ports are said to be short circuit respectively in the experimental measurement just now, G is called the short circuit conductance parameter. You may think that, can we measure the G parameters of any two-port networks by letting the port be short? In fact, we cannot. For this two-port, if inside the network there is a controlled voltage source in parallel to port 1, there will be a mistake in analysis when port 1 is short. So we can't measure all the two ports G parameters by letting two ports be short. It's also one of the reasons why we need several parameters to describe the two port. From the two circuits that two ports are short respectively, we can see that I1 equals G12 times U2 when port 1 is short, and I2 equals G21 times U1 when port 2 is short. If G12 equals G21, it's a reciprocal two-port, which means exchangeable intuitively. If two voltage sources are exchanged, the corresponding currents flowing through the other port are same, so the two-port is a reciprocal two-port. You may learn reciprocal theorem in the following lectures or courses. We can prove that a linear resistive network definitely satisfies that G21 equals G12 by reciprocal theorem. It means that the resistive two-port network must be a reciprocal two-port, but a reciprocal two-port may not be a resistive two-port network. You should pay attention to this.